Course 3, Lesson 14, we are looking at our equations and evaluating and solving them by inspection rather than our computations that we normally do. Okay, so let's look at some examples. First, let's look at some vocabulary words. Variable, we are using a letter to represent a number. A constant is a number that never changes its value. So if we look at a normal equation like P equals 2L plus 2W, P, L, and W are our variables where we could input different information with them. If we have something like Y equals 2X plus 3, X and Y would be our variables, and plus 3 would be a constant, because that's a number regardless of what we put in for a variable, that number will never change. So, if we look at this example here, a taxi company charges $2 for a flat fee plus $3 per mile, and so the cost C in dollars for a taxi ride would be shown by this formula, 3M plus 2 equals C. So if we end up with a ride that costs $20, let's find the length of the ride by solving the equation. Well, from what you've probably done in the past, you would say, okay, 20 equals 3M plus 2, because that would be the cost equaling 3 times the number of miles plus $2 for the flat fee. And we would say, well, let's undo that addition with subtraction. So we have 18 equals 3M, and we divide by 3 to get M is equal to 6. We need 6 miles for a total cost being $20. Well, although that's great and we can definitely use that computation to our advantage, let's think about this logically. And that's what this whole lesson is about, is being able to look at equations and logically think about them, saying what number is the only one that makes sense here. So if we look at our original equation, 20 equals 3M plus 2. What I can say to myself is, what number, M, what number, if I multiply it by 3 and add 2, would get me up to 20? Well, that means that if I take a number and multiply by 3 and add 2, then I'm looking for a number that really is a number times 3 equaling 18. So what number times 3 equals 18? Well, that's 6. So just with some logic and knowing what we know about numbers and adding, subtracting, multiplying, dividing, we can logically think about this and find that it's 6. So let's look at some other examples. Let's look at these one at a time. So 5 equals x minus 13. What I can say to myself is, and this is kind of like a checking method, just to make sure that you understand what it means to have our equations and solve them. For 5 equals x minus 13, we could say to ourselves, what number minus 13 would give me 5? Well, if we know, that means that, all right, I need a number that's 5 units away from 13, but it needs to be bigger. So 5 units away from 13, that would be 18. So 18 minus 13 does give me 5, so x would need to be 18. Let's try another one. 20 minus x equals 12. So I need a number that when I take that away from 20, I get 12. Or 20 minus a certain number gives me 12. Well, the only number that works there is 8. X would have to equal 8. This is really good for things like this one, where normally with our method we would say, well, 20 minus x equals 12, so let me take away the 20, and I would have negative x equals negative 8. What in the world does that mean? Well, in this case, all we have to do is think about it logically and see that we have an answer of 8, because that's the only thing that 20 minus 8 gives me 12. Let's try another one. 9w equals 45. So 9 times a number gives me 45. Well, the only number that I can multiply by 9 and get 45 is 5. And how about if I take a number and multiply by 10 and then add 2, I get 22. Well, that means that I need a number times 10 that gets me to 20, because then I get 22 once I add 2. All right, so I need a number times 10 that equals 20. Well, that means that x equals 2. 2 more. I need a number that when divided by 4 gives me 48. Well, let's see. If I take 100 and divide it by 4, that would only be 25, so I need a bigger number. How about 100 and, I don't know, 160. 160 divided by 4. Well, that gets me to 40. I'm getting close. All right, how about 180? I don't know, 180 divided by 4. Well, that gets me 4 into 18. That gives me 4, 16. I have 20. So I get 45. I'm getting closer. I need 3 more. So that means I need 192. 192 divided by 4 gives me 48. So x has to be 192. That's the only number that when divided by 4 gives me 48. And lastly, if I take a number and divide it by 4, then subtract 5, I get 3. Which means that I'm really looking for a number that when divided by 4 gives me 8. Okay, because if I don't subtract that 5, then I get 8. So I am looking for a number that when divided by 4 gives me 8. Well, the only number that I can think of is 32. 32 divided by 4 gives me 8. And so I can subtract 5 and get to 3. So my x is 32. So we can logically think through these questions and say to ourselves, almost like a riddle, what do I need here? What is the only logical answer? So you can see some other examples for this where we can logically think about these and solve by inspection. And also you can practice evaluating just by plugging in numbers. 4ac, so 4 times 1 times 12 gets us 48. So things like that. Okay? All right, well, I hope this was helpful for your homework and for studying.